Okay, so where we left off, we had just drawn our 4.5 kilometer vector, and then she turned. This was 60 degrees, and then she walked 6.4 kilometers with respect to it. Maybe I should make this bigger so you could actually see. Okay, and so then our resultant will be in here. So, switching. Sorry, just trying to get it to balance so you can still see. Switch colors. Draw it in. And when I measure mine, I get like 5.9. 5.8, 5.9 kilometers. And then measure the angle with respect to the one that you started with. So put it right here along here. And I get almost, not quite lined up. I get almost 80 degrees. Okay, so at an angle of something like maybe 79 degrees. This time I can't really do the north, south, east, west because it didn't tell us that she was going north. So we can just say 79 degrees WRT with respect to original direction. So whatever way she was walking originally, now this angle is like 79, 80 degrees with respect to that. Okay, so that's number 10. All right, I didn't assign number 11 because it was actually the one on the examples sheet that we did yesterday in class. You may have noticed. So now we flip over to page 102. So page 102, the other one I asked you to do last night was number 17. So it says a hang glider launches herself from a high cliff and drifts 6 kilometers south. So this is number 17. So first she's going 6 kilometers south. And the wind begins to blow from the southeast, which pushes her 4 kilometers northwest. Now, whenever they say northwest or northeast or southwest, it's implying a 45-degree angle. So whenever it's 45 degrees, technically you don't actually have to put it in there, so you can just say northwest, but it means north 45 degrees west. Okay, so again, you could either use 1 centimeter equals 1 kilometer or 1 centimeter equals 2 kilometers. First one is going totally west, or excuse me, totally south. So, and it's going to be 6 kilometers, so we'll line it up here. And go down 6 kilometers. There it is. Then take your protractor and you're measuring from the north 45 degrees west. So line up your protractor, 45 degrees right there, and it's going 4 kilometers. So from the tip, 4 kilometers. Put your arrowhead in. So this is 4 kilometers. This is 45 degrees. Switch colors, for me at least. Draw in my resultant. No, you don't have to switch colors if you don't want to. I just think it's easier to see which one my resultant is if I switch for you. Now measure the length. I get about 43, 4.3. 4.3 kilometers. Measure the angle up here at the origin. And it's about 42 degrees, so it's not quite an isosceles triangle. Okay, so if we did the direction, I'm measuring off of the south. 42 degrees. Oh, it said west and I went east. Mine's backwards because it did say west, right? Yeah. All right. Ignore that, because that's not correct. Let me try that again. So this time, go 6, whoops, without moving your ruler, 6 kilometers south, and then do south 45 degrees west, not east. 45 would be over here, and do 4 kilometers right there. So this is 4 kilometers. This is 45 degrees. Draw in your resultant. Is this really 6? Because it looks awfully long. Oh, it really is 6. Draw in your resultant. There it is. Measure it. And it's about 4.3 kilometers. Measure your angle. It's a little bit bigger than 40. It's about 42. It will be south 42 degrees west, as opposed to east last time. Okay, so that's part A. Then it says calculate the average velocity. So for the average velocity, you're going to do VAV equals delta D over delta T. The delta D is what you just found. So it's 4.3 kilometers. And it's going to be south 42 degrees west. And in the question, it says it took her 45 minutes. 45 minutes is 3/4 of an hour. And so I would change it to kilometers per hour because I think that's probably easier than going meters per second. So 4.3 dividing by 3/4 is the same as multiplying by 4 over 3. And you should get something around 5.73. If you had 4.3 like I did, you probably had 4.2 or 4.4, but something along that lines, and the direction will be the same. The direction of the velocity and displacement are always the same. Okay, and so that is your average velocity. Okay, now the next question asks you to, question number 18, and you're going to do it for homework for me, but it says the first one, it flies 195 kilometers, oh, it's not this one, west or north 15 degrees west, and then the other, so you're going to do exactly the same thing, and then it asks you to calculate the velocity, so you're going to do this same thing as we did here. It's number 19 that you need to find the displacement vectors, and for number 20 you need to find the displacement vectors before drawing it. Okay, so 18 is normal just like the one we did, but 19 and 20 you're going to do VAV is equal to delta D over delta T and find the delta D for each one of them before you draw, and then it's the delta D's that you're going to draw just like we were drawing the D's here. Okay, so please do 18, 19, and 20 today for homework, and we'll go over them tomorrow. Thank you.